oxidation state. In the equation, students will always struggle how to split an equation into half oxidation and another half reduction. You rely onto the oxidation number of this charge number, so you can split the oxidation and reduction so that you can divide it into half equation oxidation and half equation reduction. Then you rely onto the E electromotive force number, add up the value. Then you can predict the reaction. Is it a strong reaction, slow reaction, or no reaction? So now we're going to focus on how we're going to allocate this charge number, so that we can split an oxidation and reduction. Here, a demonstration. On these four equations, S plus O2 give SO2. Who's oxidized? Who's reduced? Student, you may be struggle. The second question, copper oxide plus hydrogen gas. Who's oxidized? Who's reduced? Again, student, you may struggle. Now the rule is, if you allocate with the oxidation state number, and you need one more rule. Of this rule, at the corner, you can see I put from 0, if down, -1, -2, -3. If it is up, +1, +2, +3. The rule very simple. When you go up, it's oxidized. When the number going down, is reducing in charge. So, using this rule, you can determine the first one. Sulfur from 0 to +4, the number going up, oxidized. From oxygen, 0 to -2, you are reduced. Now do the bottom question. (0 to +2, you oxidize. 0 to -2, you reduced. Do the right on the right hand side. Copper +2 to 0, to 0, you're going down, reduced in charge. 0 to +, oxidize, you're going up. The remaining oxygen, -2 to -2, no change. The bottom one. Cl +6 to Cl +3, you are going down, reduce in charge. -1 to 0, you're going up, you oxidize. The remaining, no change. Now, we go to this oxidation rule. It divides into 4 elements. Iron, molecule. Now, let's start. Element. When you allocate the charge, element always 0, as sulfur is 0, oxygen 0, hydrogen 0, copper 0, and so on. Iron. If you are iron, you follow the charge. As 2 minus, you write 2 minus. H plus, you put +1. Minus, -1. +3, +3. You follow the same charge. Molecule. When the molecule contains oxygen, oxygen always -2. Oxygen always -2. Oxygen -2, -2, -2, and so on. If the molecule contains hydrogen, +1, as hydrogen always +1, +1. That's all the oxidation state rule. So, student, you require to know the oxidation state of this rule plus the one that I show you. Here, some practice. Now let's practice. Element. Always 0. Molecule. Remember, overall the molecule have no charge, so should be all 0. Like first example. Fe plus oxygen. Oxygen -2 should be 0. So Fe plus 2. Next one. N plus 3 times +1. Hydrogen +1 equal 0. N equal -3. Water. H2 2 times +1 plus oxygen -2 give 0. Carbon plus 2 times -2 gives 0. So carbon should be +4. Remember, molecule in the beginning, it always should be 0. The overall should be 0. And that will be different from iron. Iron will be whatever the charge, they're not 0. So here, C plus 3 oxygen equal -2. C equal +4. Next one. S plus 3 times -2 equal to 2 minus. S equal +4. Next. 7 Cl2 plus 7 times -2 give -2. So Cl equal. With this rule, you should be able to allocate the oxidation state now. So now let's redo the previous exercise. The first one, what is the oxidation state? Element. S. Element O2. SO2 molecule rule. What is the oxidation state? Now can you split half-half equation? Next question, the bottom. Element, element form compound. Can you split half? Next question. Careful. H2 is not +1. This is an element. It's 0. Can you split half equation? Which one's oxidized? That's the way to split half equation. Next one. Allocate each oxidation state. Check, make sure. Now, can you split half? Reduced. Other half. That's the way to split half equation by using the oxidation state number. Thank you.